My name is Selena Mosley, and on behalf of the organisers Oliver Kinross, I would like to welcome you all to London Build Online. I would like to give a big thank you to all of our sponsors, but with very special mention of DuPont Tedlar.
Thank you very much. Thank you for giving me the opportunity to seed some ideas into this discussion. So today we'll be talking about building exteriors standing the test of time. And so we see many buildings standing the test of time and looking seamlessly untired of going through the years. So first, let's have a look at what kind of stress they have to undergo in their environment. And one of the first stress that we see is the weather. The weather is composed of temperature, so average temperature, but also temperature variations going through day-night cycles, through the seasons, and sometimes also through sudden events within a same day. But the weather is also composed of water, so it could be in the form of snow or of rain, but it is also cycles of dry and humid environments. And then the third component of the weather is the wind, bringing some mechanical strain onto structures that we know about, but it also brings with it particulates that contribute to the erosion of surfaces. However, there are other stresses that will put some strain on buildings. And this one is about environmental stresses. So, for example, where are you? Are you next to a coastal line? That would mean that you get salt water. And this salt water will be a lot more corrosive towards, for example, metallic structures. But you can also get the same phenomena with acid rain. Then if you are in a heavy urban environment, you can also get problems with graffiti. Not only damaging the surface, but then your process for restoring the surface to its pristine state could also damage the surface. And then obviously when you're on heavy industrial areas and urban areas, you might also get problems with particulate. And there's also the multiple users that go through this environment, such as our little dog there, for example. And so your neighbors are very important as the weather component of the stress envelope. So what do I need if I want to test to stand the test of time? What do I need as an exterior protection for a surface? First of all, I need a surface that is resilient to physical damage. Not only in use, but also in installation. I also need a surface that is chemically inert. So graffiti tends to be solvent-based, so paint tends to be solvent-based in the graffiti cans, for example. I need to resist this process as well as the removal process. So I will need a surface that is chemically inert. Then obviously to resist the weather, I need UV protection through UV reflective material, for example. I need to be able to handle the thermal changes. We talked about the seasonal changes and the day and night cycles, as well as sudden events. And then finally, I need my surface protection to be permanently adhered to a substrate so that it can carry out its mission of protecting it. Now, if I don't manage all of this, what will happen is I will get failure of the surface to protect the underlying substrate. And those failures can be seen in different shape and form. So for example, I can get a gloss loss over the surface and go from a shiny surface to a low gloss surface, which wasn't my original design, for example. But I can also see color changes. I can see cracking of the surface, which, if it is associated with a metallic substrate, could bring further some corrosion issues with further color problems such as brown stains and green stains. And then on specific plastic surfaces, when we get cracking, we could also grow mold and mildew, changing the aesthetic of the surface. So if I take the example of paint, for example, and I've got a good one in front of me on the wall in front of me, is that I painted this wall. And I got a fairly good paint. It settled a little bit, but that's not unusual for a paint, so I had to redisperse it. But it was a paint which was fairly expensive, high coverage, and a pretty good material. My substrate, however, so my wall, is actually not very smooth. It's got a lot of little pit holes in there. But I thought I could more or less palliate for the defects of my substrate with my paint. So I decided to clean my substrate and go with my application process, which was paintbrush and roller, with my good paint. Unfortunately, the paint has a certain viscosity. So it was good to apply because it was a fairly high viscosity, so it wouldn't run down the wall. If it had been lower with viscosity, it would have ran down the wall. But because it was a good paint, not running down the wall, it also wouldn't fill the holes that I had in my substrate. And so basically, I'm left with a wall which has little pinholes. It's not ugly, but they tend to be staring at me all the time. And so in this case, it shows that you need to have good paint associated with a good substrate preparation, associated with a good application process to have a good end result. And where I failed in this application is I didn't prepare the substrate well. So in fact, it didn't matter that I had a good paint and a good application process. I don't get a 100% satisfaction on the end result. So could I have done this differently? And now with my experience of the paint process, yes, I probably could have done that differently. And I will use the same analogy. Here I could have probably done a better job with wallpaper. Now, I'm not suggesting to use wallpaper on exterior application, but in this case, we could use film on exterior application. And the interest of film is basically you get 100% coverage. In my case, it would have been useful because regardless of the state of the substrate and regardless of the application process, it is within the quality control of the film that I should have 100% coverage. So basically my film is a continuous plane and it doesn't have any pinholes or any crack or any such thing, because the quality control around the film reassures me that I have 100% coverage. But it's not just that. I also have all the interesting physical properties that I was looking for in terms of UV resistance and chemical resistance. And this, again, is regardless of the application process and regardless of the preparation of the substrate. Now, of course, the film is customized to have the optimum surface adhesion, and then it also have a uniform thickness. Again, the quality control on the film ensures you have uniform thickness and uniform color. So if I receive the film, that means I have already this built in my exterior protection, which is the film. And it doesn't matter how I apply the film on the surface, this thickness is already there, and the color and the uniformity of the color is already there. I can get the film in a broad range of aesthetics. So if I want red film, it will be red and it will be red all over. If I want it to be pearlescent, then again, I will look at the film and I will have a direct gauge on the aesthetic of the film. And this will not depend on, again, my process and my substrate. And the film is such that it has already all the corrosion and fungi protection on its surface. So the benefit of the film compared to paint, which is dependent on the application process and the substrate, is obvious there. Now, not all the films have all of the attributes we're looking for. Some films are more or less resistant to UV, more or less resistant to water even, and more or less chemically inert. Polyvinyl fluoride is an interesting polymer because more intrinsically it has UV resistance. It's hydrolysis resistance, that means it's water resistant, it won't react with water. It is temperature resistant within a range of -70 degrees C to +160 degrees C. It is chemically inert. It knows no solvent. That means that you can write on it, you can paint on it. If you find a solvent to remove the writing of the paint, you can restore the surface to its pristine condition, to its original condition. It's also a compliant polymer. That means that it has some amount of elongation into it. So if you apply it, for example, onto a metal substrate and you want to shape your substrate or you want to bend it, you can achieve T0 bend without damaging the coating. And it is fungi and bacteria resistant. So we make a lot of claims. Those claims always need to be assessed. So you can check that you are actually doing what you claim to be able to do with testing. First testing, which is interesting, is the Florida weather. You basically place your samples into the Florida weather at 45-degree angle, and you see how your color change, how your gloss will change. But this takes time. The Florida weather is interesting for two reasons. It's high temperature and it's high humidity. And this is the worst environment for any polymer to be in: high temperature, high humidity. This test takes time, and sometimes you don't have all this time to test a material. So you will go through accelerated testing, and I could talk for hours about accelerated testing. So you have UV test chambers that you can use to test for color changes. Gloss a little bit less, because to be able to assess changes in gloss, it's better to associate your UV aging with some thermocycling. And sometimes to actually cycle between the two is the best way to assess the performance of your material, with some humidity cycles. That's why I could talk for hours about it. And you should also do some bend and deformation test. It's fairly easy to test adhesion, but again, you need to test initial adhesion as well as weathered adhesion. And the chemical resistance tests are usually very simple. They tend to be immersion tests for a certain time at a certain temperature. Now, I'm a very pragmatic kind of woman, so I like my case studies, where I get really completely reassured that something is going to work is if it has worked in the past. And so here I've put a few examples of where it has worked in the past. I put the metal tires there on the left-hand side, which are protected with a dark gray Tedlar for now 20 years in Japan. So Japan is fairly high humidity in some certain zones. It can also be with lots of temperature variations. I've put an example of industrial sites, which are particularly challenging in terms of the particulate that could go onto the surface and some of the corrosion mechanisms on the surfaces. So here we've got example of 27 and 30 years in such industrial environments. And then we can even go further in time. We can go 50 years in Paris, there where you see the nice white surfaces, which is still nice white surface after 50 years. So I'll summarize a little bit what I've said. If you've got a good paint and a good substrate and a good process, then you will meet 100% of your quality requirement. But if you fail on one of them, then you will fail on your quality requirements. This is the reason why film alone can provide most of the attributes you're looking for, independently of the process you're using and independently of your substrate preparation. All you need to worry about then is to make sure you have good adhesion to your substrate. Now, the outdoor environment is composed of many stresses that will put strain on your coatings. And so to simulate this outdoor environment, you can use accelerated testing, which will be used to predict the long-term outdoor performance. But your material selection should always consider the environment in which your building is going to live. And so you can then derive some durability aspects. You also need to take in consideration what maintenance you want to apply to your building. Do you want to clean it? If you clean it, what do you clean it with? High pressure, chemicals, surfactants? Do you really want to use surfactants? So you need to take in consideration the initial, so the weather and the environment, and how you're going to palliate for degradation from the environment. Ultimately, the best predictor of any surface protection is its actual outdoor history. Now, I'll leave you with these thoughts and I wish you a good panel discussion.